Okay. It's Thanksgiving month in America. I mean, there might be some other thing going on this month. I don't know, but really, what we're here for this month is turkey and mashed potatoes and stuffing and
Not
pie.
gravy sauce.
Whatever it is that we do in America in November, and then every 4 years, I don't know, some other kind of craziness happens.
Spice.
um, so tonight we have with us Hugo Pinto, who's in Portugal, um, and who got up especially to join us. In addition to Johnny Red, who always joins us, and we appreciate that very much. But we know that Johnny is, uh, you know, perhaps a little mentally challenged because why would he be doing this? Um, and so, we don't usually. I mean, Johnny's here and he always jumps in and helps us talk about stuff, but we don't usually have international guests on Mondays because you know it's 9 p.m. Eastern time and it's ungodly time in Europe. So this past Sunday, the Load ZX Spectrum Museum had this 3 4 hour long streaming session, most of which was in Portuguese and which went sailing right over my head, but it was fun to watch. And then they switched to English at a certain point and talked about all the things that they had been doing. Um, there's a lot of sort of outreach activities like street gaming and all this other stuff that they do. But a museum is a museum, a place that collects things and documents and etc. And obviously, in this case, they collect the stuff around the Timex Portugal plant and enterprise and the experience for folks in Portugal with Timex Sinclair computers. Um, and in the past 4 years or so that they've been at it, they've collected a lot of stuff. Some of it's kind of the ordinary thing. Those really cool black TC 2068s, for instance. And little oddball cassette players and all this sort of ephemera, lots and lots of documents too. They were very lucky that somebody preserved a ton of documentation. One of the things that they had in their collection is this largish circuit board that fit inside of one of those black TC 2068s. And it was called Tenet, Tenet. And there was also some brochures that went along with it that indicated that this was a network for an educational environment. Um, and in the U.S., we had some sort of similar systems. Like when I was in high school in the early '80s, we had a classroom full of Trash 80 computers, and there was a controller hooked up to the main TRS-80 computer. The teacher would control the thing, and you'd load software off of the main computer. And it might have done other things I don't really recall. So Tenet sort of fits in that um, that spectrum of equipment, right? But there was not a lot of knowledge about it. And Hugo Hugo Pinto on Sunday told this amazing story about how he came into contact with the museum and how he heard some of these people talking about their stories, and this inspired him to get involved. And they made this really cool video. It's like 15-20 minutes long or something. Is that right?
30, 35, 36 minutes long.
Oh yeah, it's great. I mean, it's subtitled, except when the guy in English is talking in English. Um, so it's a really amazing. It's up on the YouTubes. Now make sure you get the link. Um, anyway, Hugo got out of bed just for us. And with that, Hugo, I'm going to put the spotlight on you, and I'm going to let you tell your story.
All right, all right. Thank you, David. Well, good morning, good evening, or good afternoon, depending on your schedule. First of all, thank you so much. This is actually really fun for me. I just got out of bed, absolutely, but it's so fun to be near people that share our passion. So, well, that's what this is about, right? So, a little, can I get a little bit of a hands raised kind of thing to try to do a bit of a survey here? Who of you had seen this documentary that David was mentioning that we put on to this video that we put onto YouTube, just to know whether I should repeat stuff or not. So did you guys see it? A okay or not okay would be nice. You did it, you did, Paul, you did, Paul,
Yeah.
Peyton, and well, I would assume that most people, yeah, I would say 10-15% of you guys did. That's pretty much in line with what we saw. So I'll try not to repeat myself because I would direct you, as David mentioned, I would direct you to this amazing piece of history that we tried to produce. It's not on us, it's not on our credit, but the fact is that we did interview quite a bit of the people in Timex Portugal Engineering that were part of this project. So it's really nice for you to just go there and see it for yourselves and hear them for yourselves, because I believe the magic part of it is really in their voice and in the passion to which they speak about the things and then recognize these things when they came back to life. So without trying to overlap too much into the documentary, I will give you, I don't know, a 10-15 minute brief at most of what we did and what was Tenet. And I'll then show you a bit of it working in here. And well, apart from that, David, you're the master of ceremonies, so whenever you find that I'm exceeding my own time, please just say so, okay?
And Adam will tell you too.
Sure, sure.
All right, all right. Johnny Red, if you by any means want to drop in on any of this stuff, please don't be minimally resistant to it, because I'm just doing this as impromptu and in the open as possible. Okay, so let me give you a bit of context first, and then I will share a few slides that they're from the presentation that I actually did within that video, because that video showcases a meeting in which we got onto people onto the museum. Most of the engineering team, we got them onto the museum in this day. I believe it was the 27th of August, and to show them firsthand what we had just rebuilt. And as I do a bit of a presentation in there, and well, most of it obviously is edited out, and I have the presentation, the PowerPoint here with me. Nonetheless, my goal is not to give you a PowerPoint presentation at all, just to illustrate things with a few pictures and then get back to the real thing. Okay. So first of all, a bit of context. This was 1996, 1996, early 1996, something along these lines, in which Timex Portugal is exploring business opportunities to branch out of the purely ZX Spectrum world and onto, well, mostly European business, but not only European business. And it's starting to feel the weight of some risky business decisions, like stocking a buckload of those 3-inch drives and having people in the accounting say, guys, this might not have been the wisest choice we did, huh? So they're trying to get products out to the market, and they're finding creative ways to do it. They're building two drive systems in order to just push more drives out, and they're exploring around. They're looking around for business. And in one of these meetings that an associate for Timex was for Timex Portugal was doing in the UK. They found out that there was this business opportunity in China for a classroom-inspired networking system to support classroom activities based on 8-bit computers, namely the ZX Spectrum, and namely considering the idea of using interface one as a mechanism to support the networking interface, because, well, you do have these tiny jacks here that allow you to communicate with other computers. And they find that they could have a competitive edge in there, namely in reusing and leveraging the disk-based system, the FDD system that they had been already building for the past couple of years in Portugal, and that it would be a nice match using large capacity storage with a networking environment. It was just that interface one was probably slow or slower than what they wanted, and they were considering doing their own thing based on whatever was the FDD stack by then. And they seriously considered this within what, one window, two window, one week, 2 week window. And strangely enough, one of the things that surprised me the most during all of this communication that we got was the fact that they were very agile regarding decision making. It's crazy how fast they saw an opportunity and they took it immediately afterwards and decided, let's put resources into this and put the project plan together. This really surprised me. So they did. And this was April, and by end of April 20th, something like that. And by the beginning of May, they had a project plan and a team assembled to address this and say, no, let us try to get the business. And so they pretty much assembled that. They used David Carlin, which was the designer for the QL, as you might know, and as a lead architect for the thing. And they assembled a team of 3 to 4 Portuguese people from the engineering department, one doing the overall architecture, so David, one doing most of the coding for the system interface, the low-level stuff, one doing most of the high-level stuff, and the other one basically doing the electronics and all of this concretization of the boards that David was mentioning in the beginning of the meeting. And in May, they were doing the project. So 2 weeks after the business opportunity was found, they said this is critical for our success because the opportunity was for the Chinese railway systems. And the Chinese railway systems, they say it was huge. It had about 10 million employees, they say. I don't know how close to the number it is. They were certainly in the millions. And well, that's the Portuguese population as of today. I mean, it was the number of employees for the railways. So it was they had their own educational system apart from the official Chinese educational system, inspired in it, of course. But they were doing their own thing. So they were able to deploy classrooms to their own employees, to do training programs for their own employees' childs. And so the whole thing was set up in such a way that it was huge. As an opportunity, it was something that if you could get that business, that would sustain the company for years to come, most probably. So that's the opportunity they tried to hold on, and they started building, and they built a prototype to showcase from April. They had to showcase this in September, October to the Chinese decision makers. So this is the context. They started very, very early on in crazy deadline mode, crunch time from the beginning in order to try to have something usable by September, October. So that's our context. And the funny thing is that they ended up realizing the full system based on it. What is Tenet then? Let me go back to my presentation for just a few slides. I promise you not to do some heavy PowerPoint work on that, but this picture is well worth more than 1,000 words. So let me try to get, and my words do come out a lot, so I'll try to keep those to the minimum and the pictures to the most effective use. So there you go. Click. You guys seeing this, right?
Yep.
Great. So I won't go around too much. This tells a story of what we did during the whole process. It's thought to be a narrative kind of presentation. I will just skim through the slides that matter the most to give you a bit of glimpse of what it is. So Tenet, as you can see here in this corner, they actually had brochures for it. It's a classroom environment network based on the Timex and the ZX Spectrum platforms. It works on both systems, so you can actually use on our iteration of the technology what we realized and brought back to life. It actually works on both normal ZX Spectrums as it does in Timex computers. So it was pretty transparent to the operating environment, and it was actually quite cleverly designed. And they actually had a brochure of a classroom with multiple computers loading stuff onto each of the students' computers. I won't dwell too much. These are intro slides. Why are we doing hardware preservation at the Lodz ZX Museum? Well, things break down, so this is important. We started doing. We had a bit of a session with you guys as well 1 year ago or something along these lines for the SLC, and we actually resynthesized that into VHDL, and it's available from our GitHub repository. So that's nice. Thanks to this guy, Alvaro Lopes, which has also participated into the team that did the Tenet recovery. I actually got together for this event in this 40th anniversary presentation for the ZX Spectrum, in which these two guys, they are former Timex Portugal employees. They were telling the story about how the whole thing came to be. And it was really the trigger to say, whoa, there's this project that never came to light, which is amazing. I mean, they were doing stuff. This is 1986, so you had very expensive networking systems based on the IBM PC platform going around that would cost 10, 15 spectrums. So this was landmark, right? And for me personally, this was just trigger of, well, we need to make this happen again, and we need to try to recover it, because the only thing that the museum had by then was one and a half of these units. We had one full unit that nobody could boot because, well, we were kind of afraid of, and we had a half unit, which was just a board that would go on the edge connector. But the thing, well, didn't really know what the whole thing was about by then. And this is it. There were two main products that we knew that the museum could play a part in recovering. One was Tenet, and the other one is this legendary computer that they were eventually building by the time of the last months, the downfall. This is Tenet. This is basically a 2048 or 2068 Timex computer connected to a floppy disk system, which is connected to a printer, which basically performs the teacher's role, and then up to 24 stations, which are the students, and they are connected via this very thin 2.5 millimeter jacks. This is not it. I have those around here. Which are audio jacks, the smaller ones, and they are very inexpensive, both to build and to produce the connections themselves. The idea of the computers was to actually build this and build the network as cheap as possible to be able to scale it out to the Chinese opportunity and eventually to European schools as well. But they were aiming at doing the Chinese business first. So what we had by then was two boards, one which had this ZX expansion, the edge connector board, and one which was a full 248 daughter board, which is the same dimensions as a Timex computer 2048, which were one had a 8031 processor, the other one had an 8051 processor, and this is actually the larger one, the one that was beneath 2048 computer, which we took and which we worked on extensively. So we took this, we took high definition photos of the whole thing, as I have here. This was the other one, the edge connector one. We had this Thomson Gator rating, which was we thought it was kind of a black box in itself, so we didn't delve too much into this interface, mostly as well because some of the code that was on one of these EPROMs, this one here, reads out blank. We didn't get a good reading out of it, and in this one we actually had good readings out of all components. And there were these two things here, which was these PAL chips, which are programmable logic that we didn't know what they were doing underneath. So we took this, we took the PALs, we force brute the pulse. So we force brute all of the combinations for input and output, and got together all of the possible outputs, and then we reduce the logic mathematically. So we use all of this stuff that you get on the university, like Carnot maps, right? Long ago in a galaxy far, far away. So we basically resynthesized the logic for all of the inputs and outputs of these two chips and reconstructed them, as well as so these are actually the logics, and read the EPROM code, both for the chip which is associated with the Intel processor. There was an Intel coprocessor there. We'll get into that afterwards. And the chip which is responsible for some Z80 code, which is also on the other side of the board. And as I mentioned, we pretty much read them out correctly, except for the Z18 code on the smaller board, which is a pity because if you look at it and if you look at the timestamp, this is much more recent than the one that we had here, which is a first version. But well, it is what it is, and one must be thankful and not sad about what we got in the end, right? So we disassembled the whole thing. We took a large piece of work disassembling both the 8051 ROM, which is responsible for communication. I will delve into that, and the Z80 ROM, which is, if you look at it, an extended version of what's on the floppy disk systems. So it's basically a shadow ROM, pretty much like the interface one uses to swap, to cleverly swap the operating code on the spectrum between what's the main ROM where BASIC resides, and swapping it to some alternate code version within that same address space. And we basically disassemble the whole thing, and it's an evolution of the FDD device with the controlling code for exchanging information back and forth between the Z80 processor and the 8031. And actually, we found the original programmers there with signing their own code, which is kind of fun in a corporate environment, because personally signing code for Timex, it's kind of crazy. But Antonio Nóbrega did that, and he actually had done that for quite a bit of his own code previously as well. For example, for Time Word, he actually did the same thing. Additionally, this was harder, right? So we would have software that would need to run on for the teacher environment, because the machine would boot, but then it wouldn't do anything especially useful. We would need the stuff that was being taught, geography programs, the master control program that would allow you to do useful stuff on the network. That kind of stuff we did not have, but eventually by some strike of luck that was very, very, very fortunate, we actually got people that came together from the Timex Portugal universe, and they actually got a large set of the code, both the master control program and some educational software that was being put to demo the system in China. So we got that as well. And we pretty much rebuilt the whole thing. And at that point, we had the whole board traced out, the logic circuits reconstructed pretty much back to back with what was originally done, and we produced our own design. So we basically stated, okay, let's do our own boards, and that allowed us to create a Tenet. So what's this thing? What's a Tenet interface basically? A Tenet is basically a Timex FDD interface. The stuff that goes onto the edge connector that connects to a floppy disk system, an FDD 3000, and uses a shadow ROM and some kind of buffering for communication back and forth, pretty much like all of this circuitry that serves the FDD. Plus, it adds in logic for communicating onto the Tenet network. So what's this kind of logic? It's based on an 8051 or 8031 processor, and the 8051 and the 8031 processor, they have this natively designed feature called multiprocessor mode, which allows you, I won't delve into the details, but this allows you to set up a series of these processors in such a way that if you wire them correctly, you are able to interrupt them in two phases. by sending address bytes, so that only one of the machines on the network would be able to be signaled, and to send data bytes which can be broadcast to anyone or just to that specific machine. And it's quite clever because they use the chip processor, the 8031 or the 8051, which was shipped by then, and they leveraged the best features of it to try to offload the functionality that the network would demand, and that would be very demanding on the Z80 CPU that was running, well, its own thing. And their design goal was to have this transparent to the main computer. So they wanted the network to behave in such a way that data could be exchanged back and forth without interrupting the main computer's activity, and just at the right time, they would make data available for the Z80 CPU. It was actually quite clever. So what's in green takes care of the communications, what's in blue takes care of most of the floppy disk stuff and the paging system to interrupt the Z80. And the whole thing works while people are playing games or while people are doing their own word processing activities or whatever. So the whole thing is completely independent of whatever the Z80 is executing by then, which is actually quite cool. So this is the baseline for what a Tenet device is, and you can set it up in such a way that via this station selector here, which is a set of dip switches, you can set up the same system to be both the teacher's system, the master, or the student's system, the slave. So it's quite flexible, and we got very lucky because only because of this feature. Remember, we only had one device, right? So we can only reconstruct one device because that was the only one we had, and we were very lucky that the same design and the same device could be interchangeably used as a teacher and as a student. Okay, let me just skip into this stuff, and additionally, I will tell you a little bit about the other one afterwards. So. Let me recap. Let me close the sharing. Let me recap what we ended up doing. And I did not tell the human part of the story, which is really cool. Go check on the video. What we ended up doing is reconstructing from scratch, basically from one item. We reconstructed the board itself, the PCB, all of the components. Then we got the ROMs working and figured out which ROMs would go to which versions, and the whole thing started working. Plus the software, the effective software that would run onto the students and the teacher. So in such a way, we ended up getting the whole thing. Basically, we got hardware, we got software, we got network protocol, which we reverse engineered to try to do a unit tester for the system. And funnily enough, after we had the full reverse engineer done, we found the documentation that had the full network protocol, the whole thing laid out byte by byte, which was, well, for once it was harsh, but at the same time it was a nice validation of the fact that we were doing the right thing, and we were actually calling the same names that the original designers had for the same stuff, which is cool. Okay, so this is the baseline of what the system does, and it was built as I was mentioning. This was built from May to late June, tested in August, debugged in August, basically, and ready for Luis Bandeira, this guy, which was the commercial director for Timex Portugal, to fly to China. And he flew to China with a container with 25 monitors, plus 25 2048s, plus one printer and a whole set of disks. And he spent 60 days in China, I believe, every day doing trainings in the morning, then discussing the application of the system in the afternoon, and trainings and discussing and iterating and debugging during the 60 days in such a way that his perception is that they would be able to sell this to the Chinese railway system if they would overcome two main hurdles. One was the fact that Sinclair was going the way of the Dodo by then and had sold out to Amstrad, the main company. And additional, and so there were some difficulties regarding both the relationship with the new company and the usage of the copyrighted material from Sinclair, namely the ROM, and the fact that this was a very large project. And as a very large project, they would need to scale out on procurement and purchasing. And Portugal by then was just coming into the European Union, and we did not have a very solid capital market that you could leverage money from. And the company was already not in the best shape, so local banks wouldn't lend, and the parent company was really not in a position to tell them, okay, you got a blank check, just go do your thing. So the mixture of the two situations ended up taking the project and putting it in a drawer, much to everyone's dismay. And well, Timex was going at that point down, 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 down in Portugal. Timex Portugal was going down, 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 and they ended up not putting this onto the market in any large scale. They ended up doing this for schools, for some. They did some school demos in Portugal, and I believe some in Poland as well. But those are not as well as documented as the ones in China. So Adam is asking on the chat, was Tenet a 100% original design, or did the team cut out design time by basing it on other network hardware? Well, apart from that 8031, 8051 networking system, which is basically pulled out of the application note from the 8035 processor. If you go to the spec sheet for the processor, you see that an example of an application for a potential network would be this design. And if you look at what's done onto the Tenet system, it's line by line, pretty much the idea, but they were doing the design from scratch. They comment that they had two main inspirations. One was certainly this. This was not something that they fleshed out or that they specifically said, look, we went to the application note and checked this, but it's the same. And they were very clear in stating that this concept of swapping the ROMs, they're swapping the ROMs, not so much for the networking system, but for the FDD interface. This was inspired on what was a novelty by then, because do remember that this is 82, 83, 84 on the same team, which was basically the concept of ROM swapping was used on the interface one whenever the CPU goes to specific addresses or to an RST or to a given address to page the ROM out. And they commented on a launch. This was such a clean, amazing design that we loved it, and it was such a clear way. And so and many other hardware projects, those gaming devices that would allow you to save a game or to get infinite lives on a game, they pretty much used ROM swapping most of the time as well to run their own code. So many things were inspired by the interface one concept, which was Sinclair derived, but they took it to a whole new limit. So I would say it's a 100% original design, inspired as anything would be in these days in successful stories. And well, it built upon the interface that would connect to the FDD system. Okay, so that's the overall story for what Tenet is. I actually have a system here, so if you'd allow me, I would be connecting my phone to the meeting. And David, if you could highlight the video on my phone once I do that, I would be able to try to showcase this onto the live computers. Is that all
Yeah.
right?
Well, you need to switch your video. Um, you can do this. I've done it once in a while, but yeah, you can switch your video from your
Because
computer to
well,
your
this
phone.
is live machines, so unless
Yes.
I couldn't screen grab. I could screen grab part of it, but
Hmm.
only on a sensor and on an emulator, and we still don't have an emulator for this. So let me
Hmm.
try to get this Zoom call on the phone. So a new Hugo Pinto will be showing up. Let me take this
Oh, I
video
see what
out.
you're saying. Okay.
Nobody is taking this out, and I will take the sound out as well because you don't need to see this. And there we go. So you'll be getting a new
Recording in
Hugo.
progress.
Yeah. Let me take the sound out. There we go. And
Um,
David, I believe you can.
I've got to remove you, and
Okay, so
you don't have video on that phone yet.
oh yeah, absolutely. So there you go. And then
Oh, there
there
we
you
go.
go. Yeah. This is it,
Okay.
right? So let's let me show you my setup. Do forgive the environment itself. It's a clear tech dungeon thing. So if I look around, you'll be seeing quite a lot of stuff generically, as well as more stuff generically. So do forgive that, right? But what do I have here? I have this 2048 with an FTD 3000 system. I have this monitor, which will be the monitor for this system. Then I have a ZX Spectrum with that monitor, and I have 2068, one of those black ones David was mentioning, uh, with another monitor. So I will just connect those. So this is one, and this is the other. I will connect this, and finally I will be connecting my main system here. So they all boot up to the same Sinclair prompt that you see typically for all of these systems. I actually should have connected my FTD first, but well, let's assume the whole thing runs fine. So on this FTD, I have a Tenet disk, which is my Tenet boot disk. I will just be putting that in. It boots, but nothing happens on the PC because, as you might well remember, on the FTD systems, we need to reset it, and it boots onto this master control program thing for Tenet. Okay.
Neat.
What I need to do here is to set up my network size, and my network size is 2 computers, right? So I'll enter 2 here, and it immediately states, okay, station 1 is okay, station 2 is okay, because they actually pinged the two computers there. But if you look at them, they're completely oblivious. They're doing the exact same thing as they are now. I can actually do enter here, do something like do a print, hello guys. And it will print out hello guys. And these they're absolutely oblivious. And if I go to the master control program and select a network scan as well, I will get the same thing, and they are never interrupted, which is cool. So what can I do with the Tenet system? So on this computer, I have a floppy and this menu. One of the things I can is obviously the most obvious one in the network, right? I can send someone a message. So I have my computer station 1 here and my computer station 2 here, and I will select M for message, select message for pupil. I will select pupil 1. There you go. And I will select a message. It's hello guys. No, hello to hello. Timex USA. Okay, but that is not the same message. Click. And the moment I did that, immediately I got popped out a message onto this computer. And I can send another message, of course, to a second computer. This is 2, which is hello again.
Can you hear me? I have a question about the messages you're sending.
Absolutely, please.
Okay, so if they're running a program and you send a message to them, what ends up happening? Does it get interrupted, or it has to wait till it ends up finishing? Or
That's a good question. So before I hit enter there, let me do a 10 print. Pardon my.
You're doing good for one hand.
I was thinking the same thing.
And now I will run it. There you go, right?
Yeah.
So hello again. I'll hit enter. Aha, what happened? The first 2 lines of the screen changed. Sorry, apologies for the flicker. The first 2 lines of the screen changed to the string I sent, and then a clear line, an empty line, so that I can separate what's on the screen to what I sent. Think of it as an overlay. And now, if I want to, this computer is stalled, if you want to think about it that way, up until the moment in which I hit OK. Their choice, their design this system. I'm not too much appreciative of it. OK, and whoop.
Wow.
It's back. but it was really interrupted as a kind of multi-processing, multitasking spectrum, which is cool. Um, I can send messages. I can show the status. I can actually show a given student's screen. So I can actually tag, so show pupil screen. And which pupil? It's number 1. Hello, Timex USA. It's this one. Or show pupil screen 2. And this instantly fetched, and did you see the speed? This
Yeah.
instantly fetched the screens for each of these students. It runs at about 33 kilobytes, not kilobits, kilobytes per second, which is crazy.
So we can't get away with fooling around in class.
Absolutely. I can actually do worse. I can reset a student, reset 1, and bye bye.
Oh my gosh.
Can you reset David?
Obviously, if I can do this, I can do I can do reset, and instead of 1 or 2, I can put 0, and 0 is broadcast. So
Wow.
That'll get their attention.
Indeed.
that'll get everybody's attention. I can actually do stuff like load software, right? It's in the classroom environment. So I can let me exit to basic here because I never know the specific program's name. So this is cat asterisk. I'm doing FDD commands here. It's going to the drive and it's giving me out a listing. I have these special files there, .l, right? So I will run again and get back to the computer. And well, let's do something funny. Load password. Which pupil? Oops, sorry. Which pupil? I will load them both. Password.l load. At a moment. It's loading on the drive. And then there we go. Everybody's got word processor now. Cool.
That's
Or
nifty.
additionally, I'm missing a return there. Or I could do, let's reset them again, 0. Or I could do stuff like a bit of a more different and more fun. After class, right? We finished early.
Well, Hugo, I have a question. So all the students have their TS Word loaded now. Let's say you have 8 computers hooked up. They're all using
Yeah.
TS Word, but they don't have like a floppy connected or a tape player. How do they save?
Absolutely. So the fun thing is that they can save onto the floppy.
The students can?
Absolutely. Students can share the 2 resources on the teacher. They can share either of the floppy drives, and they can share the printer. I don't have a Timex printer here, but they can share the printer. And they have special commands on the basic extensions, like the ones used on the FDD device, to save with a special symbol, %, save, and then they put in a file name, and it automatically gets saved onto the teacher.
Okay. So that would be how they would save from basic, right? But like, how would they save from TS Word?
From TS Word, you would have to have your TS Word Tenet enabled.
Oh, okay. So they have to be modified then.
Absolutely. So
Okay.
to have software use the Tenet network, you need to have a special set. There's this jump table of machine codes routines, and they actually have it published in such a way, or had it published in such a way that it would be rather easy to implement. But for specialty software, you would need to implement your hook onto the infrastructure in such a way that you would save on the teacher's computer. They actually did some changes to some software on those demo disks in such a way that they would be able to save and load from the teacher's environment.
Oh, that's awesome.
That's really cool. So let me actually add, let's send other stuff like, well, let me delete this and try to do stuff like, for example, there's this Mozart.l. Sorry. Loading. It's not fine art, but I believe you can hear that both computers are playing at the same time. So you can do quite a lot of stuff regarding this. Let me reset them. There. Because my kid is actually asleep two hours out there. What else can you do? You can then do stuff like you mentioned saving and loading on the teacher's computer. So stuff like getting getting students to take initiative, because if you look at what I've been doing at this point, I have been always starting whatever from the teacher's environment, right? So the whole thing, being a bit more technical, the whole thing is completely master slave. So this means that the teacher must be the one to control the whole infrastructure so that they don't have packet clashes. So for the students to start something, you need to enable use of network by pupils, E. There you go. They call it file server, but it's actually a network server. And from this point onwards, you would be able to save or load stuff onto the network, but also to send messages between computers. Why? Because the station is the master station is polling one, then the other, one, then the other, one, and the other, basically asking them at every single time, do you have something for me? Do you have something for the network? Do you have something for me? Do you have something for the network? And that's the way they guarantee that whichever network size they have, they don't have packet clashes. It's also the most significant limitation in Tenet, because this means that since you're doing this round trip polling onto the network, you have a maximum network size up until the moment in which things become sluggish. Because, well, from that point onwards, if you need to poll 25 stations and back, 25 stations and back, then the whole thing becomes a bit slower than what needs be. What is running? Let me just try to do something. So this is so network is enabled, right? So I'll take my 10. Oh, sorry, 10 print 10 print high. No, high, not you. 20. Go to 10. And then I will do a save and that like this. And the moment I hit here, this will save on that floppy. So enter. And it's saved. And now I can go to my second computer here and do a load. Oh, sorry. These pesky ZX Spectrum keys, they're much worse to work with. Load, it was high.buzz, right?
Yeah.
So once again, hitting enter here. Okay, let's do a list. No need. There you go. So you could share the teacher's environment and do quite a bit of stuff regarding this. Additionally, the students could send messages between them. Please don't make me type the command because it's a bit lengthier, and with one hand it sucks. Nonetheless, you could send messages between the students, and of course you could print out onto the communal printer, onto the teacher's printer, any of your listings and any of your code. This is very Originally, the demo environment is very basic centric in the sense that most of the stuff, since you're doing it to be thought out and to be something that is learned, they were very focused on having the basic environment ready, but they have some extra code for machine code programmers. And so some of the stuff that you could eventually not do in basic, you can do in machine code. We are demoing the system on one of these gaming events in Lisbon 3 4 weeks from now, and we will be doing or trying to do, because it's not written yet, a tic-tac-toe, a network tic-tac-toe game supported on in Tenet, and this requires that there's a shared memory area which is passed on between all stations, and this would not be able to be done in BASIC, but only in machine code. But just before I close doing all of this shaky video thing, let me show you the system itself, right? I will be how we realize this. Let me just shut down the FDD system, the master system here, and here, so that you see what we have here. So what we ended up doing is we had this acrylic board, which makes some kind of daughter board system like the one you had inside of the cases. We did not break any cases. We love our computers too much to start hacking away onto the Timex cases. But this pretty much takes the same. We thought it would be nice to have this on a clear-cut mechanism so that you would be able to see the board as we had printed it out. So we had the edge connector there. We have the two networking jacks there. You can take one. You can see that in this one. In here you have two, one going to the left and one going to the right. That's actually the Tenet network. You have the FDD device there, and then you have both the ROM for the Z80, the PALs, and the ROM for the 8081, which is here. This is a RAM chip that performs buffering between the two processors. And this is the dip switch that I was mentioning, which allows you to set the station and allows you to basically state, am I a master, am I a student, and which number of student am I? So David, let me take the video out so that you get me back to my main screen, okay? And then we'll do Q&A. Okay, so guys, this was pretty much my demo. I'm more than open for comments, questions, and discussion. As I hope you can see, this is a passion project for all of us, and for me, obviously, as well. So, well, just shoot out, just put some questions.
Hugo,
Congratulations.
I have two questions, Hugo. One silly and one serious.
Sure.
Where do you get those FDD connectors? You know, the special.
I could show you. We actually got 15 pin normal connectors, and we cut out the top part, because if you look at this in the original in plastic, they have this edge here.
Notch.
You're supposed to plug in the FDD, and these are a pain to get. There were actually two components that were a pain to get. One is one was this, which we ended up hacking away literally, and the other one, you laugh, are the reset switches, because they have this. Let me try to get. Here are these classical Timex reset switches, which are the red ones, the red round ones. Let me try to see if I can get one here to show you. Yeah, this will go. Well, this is from an FDD controller, but you get the point.
Those weird reset switches, right?
These ones, I mean, you can get them. It's 12 euros a piece.
Oh my gosh.
So it's crazy, because I never hoped that I was never expecting this to be one of the most expensive components onto the design. We were doing bit by bit, so we were trying to replicate the whole thing without any concession. So we were trying to find the damn reset switch, and we found them, but we purchased what? Not even 10. because, well, they were crazy expensive for the purpose, and we already had some plans going forward regarding what to do with Tenet. We we ended up not investing too much on it. So that was the funny one, I would assume.
Yes, and then my serious question is, um, there's another piece that you haven't talked about yet.
Okay, so where is it? João, you have one there? João? Johnny?
Oh, let me spotlight you, Johnny.
I have one. It's inside this box that I've made.
So let me give you a bit of context. Our next step would be, okay, this is nice. So it's really cool to have this 2048 system to showcase, but this is not something that we can hand out to people which are interested in, well, taking part of this journey together with us from now onwards. And we would want to both basically outsource all of the designs as well as to give you a physical device if you want to toy around with it. So we are doing what Johnny will be showing, I believe, in a minute. Let me try to see if I have mine here as well, because instead of a very So but you have the big one.
I have one of the big.
Okay, so let me try to showcase the smaller one. So we have this
and the small one.
Aha, there you go.
Hang on. Sorry, go ahead. Yeah.
There you go. Yeah. So
The
we
small
are
one
actually
and
evolving this. Go, João. Sorry.
This is the small one, and the one we have been using. So it's a bit small, and it's going to be an interface for connect to the edge connector.
Yeah.
Not this massive.
But it's pretty much the same design. So what you get on the small board is exactly the same design as you get on the larger board, with two main changes. One is the fact that the PALs, that programmable logic chips, those are resynthesized into SCLD, into CPLD, sorry, into programmable logic, but more modern devices in such a way that we can source them and use them, because PAL chips these days are very hard to find. And the other change is that it uses SMD components instead of using punch hole through components like the ones in the original board. Additionally, we took very special care in maintaining two components as punch through. One is the connectors itself, of course, but the most important stuff are the ROMs, because we wanted you guys to be able to take the EPROM out and to reprogram it as you'd see fit, to toy around with the ROMs, because we will be releasing both ROMs and the disassembly. So if you want to toy around, for example, to re-implement or to extend some features or to experiment changing speeds or whatever, we would want you to be able to basically reflash the system and to toy around with it. That's what we've been doing, and so we would want at least those two components to be able to be programmed on one of those very classic, very cheap EPROM programmers. And so those are old school chips. So through hole.
Hugo, I have a question. This is Gustavo. Hi.
Hi, Gustavo.
The Tenet needs any special version of DOS, or just use the normal?
Just the normal. So we are using this. So the way it works is that pretty much what's on that board that Johnny Red showed is pretty much the inside of a Timex interface plus the communication part. So it's one of these enlarged, and so it's transparent to the TOS system, and we have been running it with the plain A2 TOS as you would find on the original discs for Tenet. There would be, and there was a discussion within Timex regarding whether you would be able to, for example, extend Tenet into a hard disk based feature environment in which people would not write on floppies but would write on hard disk. And they discussed 3 or 4 approaches to try to make this happen, and one of those would involve extending TOS to support hard disk drives, But they were discussing whether to, well, to proceed and evolve onto that source code, or to, for example, do a Tenet board for an IBM PC in such a way that they would naturally leverage the MS-DOS file system and to interface with an IBM hard disk.
Yes, no, I ask this because I am user of the FDD3 previous to the FDD 3000, and it's compatible great. I can buy one board. Exactly, yes, this is my system, but I have the silver version for the original, the Zebra. I buy for Zebra. Yeah, and now it's
And I have
working
good news for
very
you.
well.
It will work
Oh,
on an FDD.
oh wow. And my version is 64K in RAM. I run
Uh,
CPM.
it-
Yeah.
My version is 16K and it works. I had this FDD lent to the museum for the past weeks for an exhibition that we were doing, and they actually hadn't taken any FDD 3000, and they asked me, look, can you just lend us yours? And I actually lent them this specific FDD 3000 that I showed you. And in the meantime, I got a few days with the system running on my own FDD3 with 16K of RAM, and it works perfectly as well.
Wow, great.
Wow.
Good news. But I only need to replace the M397 interface that works. I need to replace this interface by the Tenet. Oh,
Absolutely.
okay. Put me in the list to buy one.
Absolutely. Well, our idea is to do both. So our idea is to both have them pre-built because we have been doing the designs, and right now we know that we want to build at least a few dozen for our hardcore enthusiasts like ourselves to toy around and to outsource the design because, well, after all, we're a museum. We do not want to keep secrets close to our chest. We want people to learn about them. And we are aligning this to the moment in which we release those small version boards, which I would hope is by year's end or something along these lines. So it's a nice Christmas gift.
Adam just, so Adam said you need to buy 8 or 10 more 2068s. And I asked the question during the Sunday thing of, what's the maximum distance, right? And this is, classroom size thing. And so it's, what, tens of feet, you guys said.
Formally it's 100 meters.
100 meters. Oh my gosh. Okay. So, all right. That's even longer than an American football field. Unfortunately, that doesn't reach my neighbor 20 miles away from me. So the best I
Doesn't
can
reach
do
Ryan either. Sorry.
doesn't reach Ryan. Exactly.
Yeah, that's the important part.
You can get line repeaters. Run that cable.
Thank you, Paul. You're going exactly where I was thinking. Is we need to, design a repeater system just like packet radio. Yes,
absolutely. So let me delve a little bit into that. So there were some slides by the end of my presentation. Let me try to see if I can pick those up. Share screen. Let me get there. Play from start. Whatever.
Oh, he's doing that, Dave. If you're going to design line repeaters, you also have to power those off the line.
Well, I was actually thinking, you know how they used to have those RS-232 to, adapters for Ethernet? Then we could do the same sort of thing as, Tenet to Ethernet or Wi-Fi.
There you go. Now
just hack a Wi-Fi connector onto the Tenet.
Absolutely.
Device.
So play from current. So you guys are seeing this, right?
Oh, no, we just see you.
Oh, sorry. Apologies. I
Shared.
hit the button.
There you go.
So we set ourselves for basically 3 stages of evolution in this. One was rebuilding the thing. So rebuilding the original classroom with the TC 2048, and hooray, that's clear. Second phase would be to rebuild a new Tenet, what we're calling Tenet 2024 or Tenet V2, which is basically what Johnny Red showed you on the smaller board. So this is pretty much the same board. Yeah, that's the one he's showing on his tiny window. Pretty much the same Tenet interface, bit by bit. We don't want to change a thing here in such a way that you could still toy around with the same thing. And then and basically what we're delivering basically is a Tenet programming kit, a mixed classroom, so you'll be able to mix these and the previous ones transparently. And this is something which is something that we can give out to the community in such a way that we're not damaging the concept, but we are still holding the same system. And of course, guys, this is obviously what we would be aiming at, which is, well, we need to connect. We need to get our guys working in a virtual classroom with the US guys, and having some kind of server, Tenet server on the net somehow, and probably, and I'm saying probably because we are not proposing a design yet, but this would be something along the lines of having either an ESP or some kind of network-enabled device on to side by side on the board, and to communicate that and virtualize TCP on top of it in such a way that you'd be able to go through a TCP network, be it wireless or be it wired, and to configure some bits onto the TCP interface in such a way that it recognizes a Tenet server, for example, you set up on the deep switch, you set up your station number, and you do this on very simple commands, ideally in such a way that you don't require a programming console to do so, and to be able to use the same primitives, well, for games, for whatever, via an open network or obviously the internet. So clearly we are on the same page, and clearly we're thinking onto the same lines, because certainly we would love to connect these to the internet.
Right, exactly, Adam. We just chat in real time with our
Yeah,
time.
absolutely. What many people taught us was, well, you guys, this is a chat bot, this is a chat room, sorry, this is a chat room onto ZX Spectrum. Well, it's more than that, of course, but certainly we would be able to do some kind of IRC-like communication onto our machines, our little machines, which was cool. But let me take a step back. This kind of stuff, the bill of materials for the 2048 board, which is the one I have here and the one Johnny Red had with the components, this was at the same price level, even if lower, most probably lower than a ZX Spectrum or a 2048 machine, which is crazy because this was not even $100 by then. And they would be able to scale this out like crazy should this have hit the market. Really cool.
That's amazing. Absolutely amazing. And how long did it take you guys to recover this?
Well, it was an on and off thing. We were very, very lucky. So the whole endeavor, I probably could condense how do they say it? Vision in hindsight is 2020, right?
Yes.
So we could condense the work probably in 2 to 3 months, but we took about 2 years. Why? We didn't took 2 years of work. We took on and off experiments. We started with the Pulse in 2022. We knew that we had the Pulse right, which by the way, we were wrong. We didn't. We were missing a line. There was one
What do you
formula.
mean? What do you mean by that pulse? What do you?
Pals.
The PALs, the programmable array logic chips. So there are.
Okay, pals. You're saying.
Yeah.
Oh,
Okay,
sorry.
Sorry. I thought you were saying.
Sorry, my
pulse. Okay.
pronunciation.
No, it's cool.
Those two.
Yeah. So these two here.
Yeah, I follow now. I just
These two here, we did not know what was in there. So that was actually for us, it was the hardest problem. And we tried that one first. And the way we did it is that we got ourselves an Arduino and some binary iterator on top of it. We knew which pins were input, which pins were output. So we tried every combination of input and got every combination of outputs possible. And this got us a huge ones and zeros map of all of the potential states that those chips would support. It turns out that one of these chips is the controller for the FDD switching, and the other one is a special multiplexer for the Tenet signals and ROM selection for Tenet. But in the end, we ended up getting all of these ones and zeros together back into mathematical formulae. And this is basically the formulae that you need to put in, now already reconverted into math, so that you would rebuild the same map. So we basically did some inverse math on top of all those ones and zeros and got a lot of the logic for each of these components, which was really cool and was our first main concern, which was, can we address that? Because if we wouldn't be able to address that, then that would be a problem. So that was one. The second one was the fact that we needed to rebuild the board, and we did rebuild the board, but then we were debugging what was wrong because obviously the first machines didn't boot. We were toying around with probes, trying to figure out what was wrong. There were so many things wrong that I don't. I kept the journal, but I don't have by memory the number of iterations that we did. Stuff like vias that were adjacent onto the printing board and were making contact. Stuff as stupid as that, but as well stuff as complex as one of our ships was plain dead wrong. And since you didn't know that the whole thing was working or not, you needed to test each ship individually to try to figure out which one was the culprit, because well. It wasn't tested, so you didn't know that whether the system would be running okay or not. Plus, we had this internal bet within the team in which some people would say, it never did work, Hugo. You're crazy. The whole thing is
That
a
was what I was going to
fraud."
ask you. Like, were you sure that it even worked to begin with? Okay, but you answered that. Okay.
Look, we had stories. So people in Timex, they told us that they had demoed it to both the Chinese guys and to Portuguese classrooms. So we knew that something had to work. We just didn't know whether the system that we had in the museum was an early prototype or so some kind of interim work or not. And we were afraid because on the ROM, on the Z80 ROM, there is a copyright 1980 by Antonio Nóbrega. 1980 was obviously the wrong date. So maybe we were thinking maybe this is just a very pre-production work, and they didn't even know the year that things would go to market. So maybe we have the wrong system. So we were not 100% sure at all. Let me just get a question here. Peyton is asking on the chat, does the new Tenet network work without the FTD master? Well, the system itself, so if you put master and slave onto the correct dip switches, you can perform some work. So you can call the machine code hooks that would send packets back and forth, and you can call so you can send a message. It's troublesome, but you can do it. And that was actually what we were aiming to. David was asking, did you guys, how long did it take for you guys to do the whole thing? It was an on and off thing, mostly because of stuff like this. For example, we knew that we would need some software to be able to run the classroom, and we originally didn't have that. So we had partially reversed the protocol, the network protocol. So we were planning on doing our own version of the classroom control program, because we were not expecting to find it we had run through all of the museum's FTD disks. So we certainly were not able to, or at least imagine what the system was. The thing is, well, we would be able to run the system without the FTD, and most probably without the disks. But we were very fortunate because one of the guys we had this commemorative lunch for Timex Portugal employees, and we barged in and actually took a mic. Look, guys, if you have anything saying Tenet at your home, this is the moment to contribute, huh? And at that same lunch, one of these guys, Rui Viotti, actually had a box of discs out of his pocket. Guys, this might be it. And he showcased a set of discs saying Tenet precisely. It was the teacher's software. So we got very lucky, and the whole thing was on and off. We were aiming towards the completion, but
So that seems like something out of a movie. Like you'd be watching,
absolutely.
like, right? You know, like what?
Absolutely. We wanted to tell that story on the film, on the YouTube thing we did, because it does seem like a narrative coming out of a movie. We were very, very fortunate. So the software, all of these reading the pals, and then we actually had it wrong. So one of the pals was not working, which was leaning towards the conclusion that this was not working in the first place. So it was really all of these hurdles back and forth up until the moment in which we connected the whole thing. I actually have a video done here in my house in which I first sent a message to one of the students, and the thing just popped up on screen, and it was really one of those haha, damn it, we did it moments. So another question from Gustavo: does there exist a manual for Tenet? There Yes and no. So they never built a formal user manual. There are some drafts that we found, and we will be publishing those together with a small board. That's our main milestone for putting information and putting stuff out. We will be putting some of the documentation that we have out, most of it, I would say. Again, taking into the museum's guidelines, we are typically publishing anything that does not have personal information up until clearance from the people involved, and manuals and stuff like that. They do not have personal information. We have we have letters back and forth from people, and we are trying to figure out how to either get clearance from the involved parties, or just to conclude that those do not hold any kind of privacy value, and we'll be putting them out as well. But our release window is together with the shorter board, and there is kind of a draft for a manual. We built our own guidelines, because the manual itself, do bear in mind that these documents are very compressed months in history. So they iterated very fast. They were actually quite an agile business unit, because there were plenty of iterations, and you see in the project plans that they were revising stuff back and forth. And even on those basic extension commands, it started using the @ in BASIC, the @ command in BASIC as a signifier, as a discriminator for Tenet commands, and then they switched to the ampersand symbol afterwards. So the manual actually sometimes reflects the previous notation. If you go to the Tenet Computer World website from Johnny Red, if you go to Tenet, to the page from 4 days ago, something like that, you already have the new commands in there, explaining pretty much what each does. So it's on the Tenet page. He edited that out on the Sunday before we showcase the whole thing.
No, okay, but if you or the museum need any help for
Much.
create the Spanish manual or version of the
Absolutely.
manual, please contact me. I'm available to
We will
help.
do our condensed version of what's
Yeah.
being taught, and then I can comment you out and shoot you out an email of what stuff do you feel comfortable translating. User manual will be nice. Absolutely.
Yes, no, but the idea is because I am Spanish native, and
Yeah.
and also know the technology. It's easy to.
Yeah.
to
You were
translate.
very interested from the get-go, Gustavo. So really nice.
Thank you, Hugo. Thank you, Shani. Bye.
Okay, guys, keep them coming. But this was mostly I wanted to give you guys an overview of what the system was. I believe, well, at least I hope the passion comes across, but the capabilities of the system, I hope it does as well. And what we're trying to put on afterwards, apart from these V2 and V3 boards, is just trying to fine tune the ways in which this can be used. I'm a firm believer that these 8-bit computers are a wonderful platform for education these days, because I believe this was not the last, but probably the generation before the electronics generation before the last, in which you could fully understand the machine back to back, from software up to the down to the bits, and still explain how a computer worked. If you go into protected mode and the 386 and natively multitask and protected architectures, you kind of start losing the thread while you're trying to figure out how things are happening. And explaining this to a youngster these days, it's much easier because you go back to the basics and then evolve onto something which is usable. So we are trying to figure out how to pinpoint this and how to leverage stuff like Tenet to do some kind of introductory work and some introductory classes to, well, computer networking, to programming on this kind of distributed systems and so on. So clearly we probably will be fine-tuning software and be able and trying to both keep the original artifacts, because after all we're a museum, but trying to add on to them in such a way that they're becoming more useful for people today.
Wow.
So you're saying in 2025 the schools are going to get them finally?
Well, some schools, some very bold schools that would love the retro vibe of doing gait fitness.
Bold and forward looking.
Absolutely.
So I have a question, Hugo, about, you mentioned earlier the Spectrum interface that has the like the network capability, and I know it existed, but I don't. How does it compare to Tenet, or does it even compare at all?
You're talking about
The interface one.
let me open the question. You're talking about interface one or these
Yeah,
new
the interface one. Yeah.
Interface one?
Yes,
Yeah.
exactly.
So interface one has these two jacks here, and they work. They are audio jacks, 3.5 millimeters instead of 2.5, and the physical connections, they look the same. That's actually, during all of these months, Gustavo was actually wondering in one of the mailing lists, look, isn't this something based on what the IF1 guys are doing? And we were very careful in stating no. It just looks like it, and I believe that's mostly the question. It just looks like it. So if you look at the interface one, let me see if I can walk the book here. Where do I have it?
Because the interface one also is very slow, right? Like it's not as fast.
Yeah. I this came up on Sunday as well. The interface
Okay.
one is something like 3.5 kilobits.
It's 10 times slower. It's 3.3, 3.5 kilobytes per second. And you're able to use it from both a basic and machine code standpoint as well. But the commands are taught to be peer-to-peer. So you set up your own ID and you are able to send back and forth stuff, and it's blocking. So the moment you need to have one of the machines waiting for the request of the other from a user standpoint. So you need to get something like I will be sending this guy this program, and the other guy must state I will be loading from that other guy this program. So it requires orchestration between them in such a way that two machines using this will be consciously exchanging information from a user standpoint and from a basic command standpoint. There are two amazing books, very small ones. One is this, the Spectrum Microdrive book from Jan Logan, of course, in which they delve into the network protocols and stuff like that for the IF1, which is really cool. And there is the IF1 ROM disassembly, which is also very nice. I don't have it physically, only online. I have it coming by email actually, which basically disassembles the whole shadow ROM interface that they had in here. So it's really not the same product. The design constraints they had for Tenet was for it to be able to be used on a collaborative environment, on classroom or office, but in which there would be, the whole thing is master centric. So it's client slave from the get-go. And as you've seen, the master owns pretty much all control regarding what's happening onto the pupils, onto the students' stations. This was much more peer-to-peer, and the design goals were completely different. This was a very collaborative, but very explicitly collaborative approach.
No, my question 1 year ago, starting because I know that Timex started with the TS 2060. This is the VEU expansion. And also important part is that Timex has the source code of the interface one on house. And that's why I ask you, because if this is a continuity of those projects or not. That's why I asked you last time.
Sure. Well, I don't know if they had the source for the interface one, but what David Carlin ended up doing was to create something which, as you saw here today, is completely different. And the software itself is based on something for which they indeed had the source code, which was the FDD interface. So if you look at, I disassembled them all at this point. For the past few days, I've been going back and forth trying to reconcile another version. Well, strangely enough, after we done all this, we got another Tenet completely working device out in the open. So a guy that had his aunt was working on the factory, and she grabbed one, I believe, something along these lines, and he kept it on a drawer, and he posted 4 weeks ago, not even, a picture online in one of the Spectrum groups, not even a Portuguese one, and he posted something like, "Guys, do you know what this expansion for the 2048 is?" I was browsing the internet and looking to it, and well, eyes popped out, right? That's a Tenet device. So I actually contacted the guy, and he was amazing because I told him the story. And he said, "Look, I can't do this. I can't do anything with a single device. So if you guys at the museum want this, it's yours." And we countered that with, "Okay, but then we will give you 3 of those smaller boards so that you can test it out on your computers as a compensation once we have those smaller boards built." And well, everybody's happy. We will be giving him tickets for the Lisbon Games Week thing afterwards so that he can see the system running on a demo bench that we'll be having there. It was very, very fortunate. But it has a different version of the ROM, a slightly different version of the ROM for the Z80 processor. And I started disassembling that too and comparing it back and forth with what was missing. Most of the stuff is error correcting and most of the stuff is minor. So I do believe that by July 1986, they had the system pretty much designed, and most of what happened afterwards was fine tuning and error fixing.
Oh, great.
Hugo, like I said on Sunday, this is an amazing accomplishment. I mean, it's been what? I hesitate to say 38 some odd years, right?
Yeah.
Uh,
Nearly 40, yeah.
almost 40 years. And you've pulled not just one rabbit out of a hat, but an entire network of rabbits.
Indeed.
And I mean, to recover the hardware, recover the software, etc., is one thing, but then to reproduce it and make it available for folks to, build upon that and do, new stuff with it. That's just a whole nother level unto itself. That's, congratulations to you, to Johnny, to everybody else on the team, and everybody else, at the museum, because this is just a huge thing. I mean, I spend time scanning, magazines and documents and whatnot, and it's cool to look at that stuff, but this is a big deal.
We were thinking, well, first of all, thank you for that. And I didn't want to put out the cliches saying that no, it was a team effort and so on, but it was
Yeah.
indeed. Johnny had all of these devices to read and reproduce the floppies and a huge knowledge of the Timex internals. There were countless times in which I got to WhatsApp and asked him, "Look, this port, when you put stuff onto this port and whatever," and he knows it by heart. Damn it. Crazy. The Johnny was absolutely outstanding. We have Paulo Silva, which did pretty much all of this tracing for the board, which built the effective boards. We had multiple iterations. This would not have been possible without Paulo.
The
We had
500, the 548
yeah.
solder points.
There's a tiny secret there, which is the number of solder points that you have on this. It's 538, I believe.
48.
48. So without Paulo, this would not have been possible. Alvaro was a huge push from the get-go. because he had all of this stuff from the SCLD already ready for the scanning and for the force brute stuff. So really was a team effort. Apart from that, it took quite a bit of pushing, quite a bit of going around obstacles. But well, this is what the engineering efforts typically do, right? And we thought of it as just like that. We are doing re-engineering on top of the original stuff, and mostly I don't say this lightly, in honoring the people that built it, because one of the things, one of the main drivers when the whole thing started was the fact that this was going to oblivion, guys. This was absolutely going away if this work hadn't been done. And when I looked at all of those stories and that event in the 40-year celebration for the ZX Spectrum, in which those Timex Portugal employees were there, what really moved me was the fact that crap, this cannot go into darkness after all of these folks died. We need to register this somehow.
Yeah.
And this gives you a huge weight and huge responsibility in trying to do so. And I believe that was an extra push for completion as well.
Yes, all those things. I agree. I mean, this is we get together and we hang out, right? For these meetings, but I have an ulterior motive in some of these meetings, and it's to get people like you to talk. And I see that we have Bob Fisher with us today, and Bob's a good example of part of that ulterior motive. Bob was a person who took a program that one of the other folks in the Timex community, the US community, wrote, a program called Profile, and then built upon that to do his own solve problems for himself, but then solve problems for other folks as well. And I've managed to gather information about this just based on documents that Bob had published, based on references in newsletters. And then I tracked Bob down and I'm like, Bob, you got to come talk to us. And Bob's like, why would I do that? You guys aren't interested in my story. I was like, oh, yes.
Of course we are.
And so I'm glad to see you back, Bob. Let's put it that way. Yeah, thank you so much, Hugo. Go get some sleep.
Well, please don't judge me too harshly if I will, because I actually came out from a kidney stone incident just today. So I got a few hours sleep and then woke up here. So I'll do some rest now. So don't judge me too harshly. I hope it was nice. Please email me on the mailing list with any questions that you might have. Johnny here is part of the team, and he probably knows how to answer this just as neatly as I do. Probably I just speak more words per minute, but apart from that, he's just as capable. So do shoot me out an email. Do keep up an eye for news on the Load ZX front, because we will be publishing most of this stuff. And if you have any question, don't hesitate, because this is the attitude you'll see in answering those as well. Thank you guys so much.
Thank you, Hugo.
Thank you very much. Awesome.
Thanks. Bye-bye. A real pleasure talking to you. I don't say that lightly. A real pleasure talking to you as always. Bye-bye.
Wonderful. Absolutely wonderful.
Thank you. Thank you, Hugo.
Wow. I did not expect that. I thought Hugo was going to talk for 20 minutes.
Well, he's very excited, so he wanted to share,
Well, and it's a huge story, right? I mean, it took them all those years. And they had all, like you were saying, Adam, that sort of movie unbelievable moments of, oh, hey, let me pull this out of my back pocket.
Right.
Look what I've got. Anyway, so we have about 30 minutes left, and I want to open the floor to y'all and see what y'all want to talk about.
Well, you did have one other thing on the agenda, actually.
The Pico update?
Yeah. You want to talk about that?
I can do that quickly because Ricardo's not here.
Oh, well, we could do it for next time then.
Oh no, because Ricardo might be able to do a demo next, but I'll give a sort of a quick update. Is that Ricardo has spent a lot of time adding and improving some of the features of the TS Pico. To such an extent that it's going to require a new manual. Um, he's, you know, and he had his own idea in terms of like the set of features that needed to be implemented. And one of those features is, for instance, that you can load a doc file from the SD card into the static RAM on the Pico. So it would be there temporarily as long as it's powered on. Or you can load it into a slot on the flash ROM on the Pico so that it's available there all the time. And so you could load, for instance, states and capitals, the most important, program there is. You can load states and capitals into Flash and have that just right at your fingertips with no delay. Or, maybe Budgeter if that's your jam. Those things can be available immediately to you. Um, so these were features that Ricardo wanted to get into the Pico and get out, and he came up with a means of distributing the updates that don't require us to program new ROMs for the thing. That you can update it from an SD card and not have to use special connection to your computer or something. And so we've been working on testing out those features and debugging it. And Ryan, meanwhile, has been working on a program that gives you a menu system, a menu front end to the Pico. So you don't have to you don't have to type in the commands to load programs. You can just sort of navigate to the directory structure and say, this is the program I want to run, and it'll do that. And Ryan has been working on making his program also load the doc files. So you could load, Flight Simulator from within Ryan's program. And one of the things that Ryan sort of ran across was he didn't have a way of knowing what the status was of the Pico, whether it was busy or whether it was free. And so, in our meetings, they were chatting about this in an email, and Ryan proposed an idea, and Ricardo implemented it, and now there's this way of, saying to the Pico, "Are you busy?" And if it's busy, it doesn't respond. But if it's not busy, it sends back a little message, and then Ryan can, continue doing his steps. So, all of which is to say, improvements are being made. We are still working towards sort of bundling this up and putting a bow on it, and giving it to folks who have Picos so that they can just put it on an SD card and do some special steps, and it'll update itself. And then you will have this whole plethora of commands and new features. And like I said, so much so that it will require its own brand new manual.
So Ryan is here still, I think.
Yeah,
Ryan, are you
Ryan's
here? Do you want to talk about it for a minute? I know you've been working. Ryan, are you there?
Yeah.
Yeah. Do you want to talk about it or anything? And we can save David's voice a little bit.
Yeah, I was been working on it while we've been talking here because I was
Bored or what?
modifying it to use the new feature David just mentioned, which was basically, hey, let's just basically kind of like synchronize, like wait till it's not busy. Okay, now let me give you another command, so that you don't have to worry about hitting it when it's busy, and then there being either an error. So you're already having to handle an error condition because within BASIC, the communication back and forth is pretty limited, because basically you call the TPI command, save or load, you don't get anything back from that except an error or not an error. And so you have to use the error trapping to say, well, okay, I didn't get an error, so we succeeded. But if it's busy, you'll get an error. And so then you got to figure out, well, was it busy or is it dead? You know? And so basically it's, and then other commands, like if you do a load and it errors right away, the Pico's not dead. It's just that, hey, it didn't find the file probably. Or maybe the doc file is bad. And so it'll just give an error. And so the waiting for the Pico to be ready function lets you just know that you're not getting an error because you're waiting on the Pico. You know that if you got an error, it's because the command failed. But it also handles that if you continue to get an error after some long time period, it says, I think the Pico's gone, and then just stops. That's the other possibility. That just happened here in testing. So there's still some conditions that I'm still not quite sure why then that happens, but I'm still debugging, so I may have had some wrong statements that caused it to go strange. So plus as we had been discussing in the Pico development, is that, you know, like there's especially doc files, there are doc files out there that are unusual, I guess, in that so the Pico refuses to load some of these. It looks at the header bytes and
for people who Ryan, for people who don't know what a doc file is, will you just tell them what that is?
Well, that's the I guess the sort of a ROM file version of a dock cartridge. So made for emulators, basically, so that it basically says, okay, here's the ROM image that would have been on the cartridge, plus a few bytes to say how the circuit would have been set up as far as the what memory segments it occupies, basically. And so devices like Pico can read that file and say, oh, okay, I know what memory segments to load that code into in the memory space to make it appear as though the cartridge is connected. And so a lot of these hold games that then you could, as a way of loading them as if they were on a cartridge. And some of the files we've been coming across, you know, the Pico just says, no, it's a bad header that identifies how it's configured. I don't know offhand. I haven't looked at the rules that why it rejects some, but obviously they work in other contexts. I don't know if it's because of the way the Pico works that it can't use all of them. Haven't really discussed that, but so basically I'm having to go through these and say, well, this one the Pico says it will not load, so okay, I'm not going to try.
So Ryan, I'm going to interrupt you just for a moment. I know that David wanted to open up the floor, and we only have like 15 minutes left. Maybe we can save some of that for the next meeting. David wanted to say, why don't you say what you were going to say? Thank you, Ryan.
Oh yeah, we can do it. We can do a deep dive. But yeah, what Ryan's basically, you know, his point is correct. There's a whole bunch of official cartridges that were made for the 2068, and then there are out on the internet a whole bunch of things that are cartridges for the 2068 that are various kinds of weird things that seem to be just like a snapshot. And people figured out how to pack, the Spectrum ROM and this program into a cartridge file, and that can cause some challenges. Stuart is with us. Stuart's been away for a while. Hey, Stuart.
Hi there. Can you hear me?
Yeah.
Good. I wanted to just take about 5 minutes to explain that I guess it was more approximately January of 2023, not this year, not 2024, but fully almost 2 years ago. I expressed in a Zoom I was interested in figuring out how the Timex interface to the how the ZX81 and Timex 1000 interface to its printer, wondering if that could be, if once it was understood, if it could get something else to talk to those printers, specifically on like an Arduino Uno. And you guys recommended that I contact Tim Horner. He had a similar interest. Well, I contacted Tim, and not only did he have a similar interest, he already had a printed circuit board and pretty advanced, complete treatment of that issue. He had code. Anyway, I ordered a couple of his boards. I made some minor suggestions about the labeling the board and the fact that people are likely to want to interface it to like a sensor. I mean, what's the Arduino going to have to print to the printer? So he added like a quick stemma connector to the board. In other words, it went through an iteration. And anyway, the project kind of went to sleep. He's working a lot. I'm just lazy or whatever. But we resurrected the whole idea I did recently about actually getting it out to the community, because he did a great job on the software. Is it possible for me to share a screen for 2 minutes?
Yeah, go ahead.
I guess if I share this, and then let's see, I say share. So anyway, I've been spending time the last month documenting it on a website. The software is fully documented and is open. He's making it open source on GitHub. But basically, this is what the board looks like hooked up to an Alphacom 32, which is the same as the Timex printer. Alphacom made the Timex printer. And, other than some very minor changes, they're the same printer. This is what its board looks like. This plugs in. This is a shield. Arduino calls them shields, like Raspberry Pi has shields. This board basically, this is one assembled. This is what he designed. And on the lower left, you see this little interface that takes a stemma connector, which is the trend that people like Adafruit are going to for connections. They're really small. And anyway, so I'm going to make it available like this, the board, and the standard components are what everybody would need to go to a printer. And they're all through-hole and very easy to put together in 10 minutes. The surface mount things take some skill. I just relatively new to surface mount soldering. I find it challenging. I'm able to do it both with a soldering iron or hot air gun, but I find it challenging. So I decided to, and that's optional because you may not even care to use that I2C interface for your particular application. But basically, it takes an Uno with this board plugged into it, goes to the printers. His software has 3 built-in fonts. In other words, it's Arduino. Use it in the Arduino IDE. Like he's got the libraries. You just pull up 2 libraries, and the library has built in these 3 fonts, and it'll print if you prep it properly by going to a website that turns like GIFs and JPEGs into, a like Arduino type code, essentially format for a bitmap. It'll print bitmaps. So here's like an Arduino one that I did, and basically, so I'm supporting on this site. I put together some assembly instructions. These are the parts everybody would need to basically print those 8. These are kind of optional depending on whether
Stuart, could you put a link to this in the
yeah,
below for us?
yeah. I just took the I guess it's close enough to being ready for prime time. I had it password protected till 2 hours ago, and I sent him the link. He hasn't had a chance to look at it, but yeah, I'll put the link in there. So
Thank you.
basically, yeah, the printers are the same, and I have a little support for the printers, mostly in the sense that people find them in the attic. Sometimes they don't remember what the power supply needed is, etc., like that, or they may want to get paper. And I've been selling paper for those printers on eBay. So but that's it. But basically, the schematic is here. It's pretty simple, yeah, this I'll put this up. So I guess my short term. And I couldn't resist. I rejoined my makerspace recently. And I have access to a laser cutter, so I decided to make a little tray that it fits in, because when you plug the stack of an Uno and this card into the printer connector, the connector is kind of up in the air a little bit, so just put a little tray together.
Can you have a
anyway,
sloped top for that, Stuart? You know, sort of an angled top?
I didn't worry about getting sexy on the top, whether I want to hide the whole thing or not. This is actually, if you sit an Arduino Uno on your laptop or something, or on your computer, you could short the bottom out.
Yeah, true.
So you have to sit it on at least a piece of cardboard or something that won't short it out. So once I did that, I figured you might as well like also support the connector at the other end, which is left, like otherwise the whole thing tilts. So it's just a fun, because I love playing with plastic and a laser cutter. And anyway, but basically, so the stack looks like that. You have the card into the connector, the Uno below it, and then this little plate kind of keeps it from. Yeah. So anyway, my short-term question is, if anybody wants one of these to actually, I have no idea like how many people have. I'm curious right now, how many people have an Arduino Uno or have ever played with one? We have a sample of 12 people here to ask.
Got about 8 sitting in a drawer.
Yeah. Okay. So some people have them. So, and then a printer. I mean, it's not really a big gift to the Arduino, to the Timex Sinclair. It's more of a gift to the Arduino people that they get to use this, printer, which is small. I found that they work very well. There's very few broken ones. There's some with lost power supplies, but I bought some used ones, and and they seem to have weathered very well. And even the paper from the 80s still works. Gives you contrast. You find an old roll of paper, it still works. Okay, so that's really it. It'd be fun to see what kind of, a kid it's good for a kid in school. If you got a kid in school wants a printer that doesn't take up a lot of room or something, and that's get logs, temperature, humidity, or some science experiment like that, whatever that's it. So that's it. So let me do one thing. Let me stop sharing my screen, if I even know how to do that. I see share, pause share. Is that good enough? Is that the same as stopping? And let me go back to the chat if I can manage to do that.
There's a way I can override this as well somehow.
Yeah. And also, Gustavo, you're still here. I'm on a kick to make this website bilingual. So if you want to play with one, I'm going to find one way or another. I'm going to get it into Spanish as well as English. I'm trying to learn Spanish. That's why.
Cool.
So here, let's see. Can I send to the whole group? How do I do that? I can
Well,
email
actually,
you.
Peyton dropped the link. He picked it off the top of your screen and dropped it into the chat.
Okay, that's good enough.
Yeah.
Then, well, I was meaning, yeah, there's
And the bank account number 2. What else was up
yeah.
All right. The important details.
Yeah. So I will have
Stuart,
I will have a contact page in place by tomorrow on there.
Cool.
And if you just send me an email that you're in a group and you want to play with one, I'll get you one. And that's it.
Cool.
Any questions? I am also curious, how many people, this is the first time I had to solder
Surface mount.
06, 03
Oof.
surface mount parts. And that little mini JST connector, that's a tough one. If you mistreat it with a hot air gun, you'll have a melted plastic. That gets just getting down there. And the little FETs that do the I²C, translation from 5 volts to like 3.3 for a sensor and a lot of these boards. How many people that's another reason I said the way I just ended up describing it after soldering a few myself. I said, well, these are the essential components for supporting printing, and the I²C stem interface is kind of optional, mostly because you need to be able to surface mount solder. I mean, in the future, I might order them pre-soldered, assembled, but for now, I'm doing it that way. Can everybody here solder surface mount parts? I don't know. I'm curious.
I've done it.
I've done it, but I don't like it.
Yeah.
Well, they do make a soldering iron that has a a needle point tip.
Yeah.
Yeah.
Stuart,
Anyway,
I have a question.
Yes.
Why the cases are slightly different between the Alphacom and the Sinclair 2040?
Well, I know they were both made by Alphacom, but I think they were made in different factories. I have the pictures up of the bottom of them. And
Didn't the Alphacoms come out after Timex quit?
Yes, they did. Yeah.
So
right. They already had production, but the Timex one is made by Alphacom. If you look on the bottom, it says they're both made by Alphacom, but I think they're made in different factories. And the mold is very slightly different. I have both, and so I haven't actually compared the boards inside. I should do that at some point. That's something else to add to the website. It's for people curious.
That's not the first device where Timex contracted with somebody else to make, a device for them and had it looked, it looked a little different. And Adam and I have been chatting back and forth about the joystick, and the joystick was made by a company called Zircon, and it was originally from the Fairchild Channel F, and it had a little triangle doodad at the top, whereas the Timex one has that big old silver ball.
Right. Yeah, I've used that system, and it's kind of interesting because when you use a channel F, like it's got a Pong built in, and the doodad that you're talking about, the triangle, like lets you rotate your paddle back and forth, kind of like.
Also,
it's interesting.
Yeah, it's more powerful than the Timex joystick. So
I wouldn't call it more powerful. It's just a little,
featureful.
Sure.
And it was cheaper to modify an existing design.
Absolutely.
Guys, it is been 2 hours. We're about ready to wrap up. Is there anything we need to talk about, David, before we do that?
Well, I just want to say, thank you for everybody who showed up. We had a pretty full group today. We had, the regulars. What do they call them? The usual
usual suspects.
Usual suspects. Thank you. That's the word I was looking for. Suspects. And folks like Bob, who came back. And Stuart, we haven't seen you in a super long time, and Mark, we haven't seen you in a bit.
I haven't even been here. I think I've missed
Adam's been gone, enjoying life, doing things.
Yeah, I was on the East Coast. I was Yep, yep, yep.
Exactly. Let me just check the calendar. Our next meeting is obviously in 2 weeks on Sunday the 17th at 2 p.m. Eastern. Y'all managed to get here at the right time with the daylight savings time. Adam,
I
you don't
actually
change,
I
right?
didn't. I like about 2 hours ago, I was confusing the time it started with the ones on Wednesday. And I asked
Oh,
Ryan, I was like, where is it? How
where's
come the
everyone?
meeting hasn't started?
Okay, well, Adam,
Well, it's just me.
so anyway, 2 weeks hence, Sunday the 17th, 2 p.m. Maybe we'll talk some more about the Pico. Maybe we'll talk some more about what's going on. I know Peyton will have absorbed the contents of all of those books that he just got, and will be telling us about some amazing program he's written in machine language.
High hopes there, but yeah, I got a lot of books to go through.
Yeah. So, thank you, gentlemen. Thank you all for showing up. It's been fun as usual.
Bye, guys.
Time to go home.
Bye, Archie.
Bye.